All right, in this video I'm going to be working BC number 1 from 2021. So this is like the operational version of the AP Calculus BC exam number 1 on the free response. And so this one's going to allow the use of a calculator. So it's talking about the density of the population in a circular petri dish, population of bacteria, where we are measuring from the center of the dish. So it kind of seems like a polar situation, but it's really not. Okay, we're not going to have to do anything in a polar way, at least. All right, so use the data in the table to estimate the value of f prime of 2.25. All right, well, okay, so f prime of 2.25 is going to be approximately equal to, I'll do rise over run with the 2 points surrounding 2.25, which is right here. So this is 10 minus 6 divided by 2.5 minus 2. And the units will be milligrams per square centimeter divided by centimeters. Okay. And if I'm asked to interpret this, the meaning of this answer in the context of the problem, I would say, well, steal the wording from them, density of the bacteria population, or maybe I'll just say density of bacteria, is increasing. Okay, I think this is easy enough. We can actually figure out what this is. It's going to be 4 divided by half is 8 milligrams per cubic centimeter, whatever that means. Really, it's the density is increasing as we go farther out from the center of the dish. When R equals 2.25 centimeters, and that's part A. Okay. Part B is going to ask us to do a right-Riemann sum on this integral, which is not really typical for us. Usually we just integrate f of x dx. So what I'm going to do is I will say for part B, I'll say, okay, remember it's the integral 2 pi times the integral from 0 to 4 of r f of r dr. So what's going to happen here is I'm going to, well, remember the Riemann sum is approximating the integral. So I'll just have this 2 pi out on the outside. And then for each term of my Riemann sum, I'm going to need to have 3 factors, right? Okay, so my first subinterval is 0 to 1. I'm doing a right Riemann sum. I need r, f of r, and delta r. R, f of r, delta r. So r is 1, f of r is 2, delta r is 0 to 1 is a width of 1. Plus, okay, over here, r is 2, f of r is 6. Delta r is 1 to 2 is going to be 1 again. Okay, this one, r is 2.5, f of r is 10. Delta r was 0.5. And then for the last subinterval, r is 4, f of r is 18. So 4, 18, and delta r is the width of the interval is 1.5. Okay, and that's how we did the Riemann sum there. Okay. It's a little weird because each term of the sum has 3 factors, but really, if we go back to what is the Riemann sum, go back to, okay, it's going to be an r value, an f of r value, and a delta r value all multiplied together. It's something that we can do. This, an underestimate or an overestimate, or of a total mass in the population. All right, now this one actually brought up some interesting discussion in my class, and I had kind of just said, oh, hey, look, f of r is an increasing function. We used a right Riemann sum, so it's going to be an overestimate. But that's only because, really, the product r f of r is increasing, because both r and f of r are increasing. And now that also brought up an interesting discussion. It's not necessarily the case that the product of an increasing and a decreasing function is necessarily decreasing, because the way the product rule works. But the product of 2 increasing functions must be increasing. Okay, so I'm going to say, because f of r is increasing, I'll conclude that r times f of r is also increasing. and therefore a right Riemann sum would overestimate. The value of 2 pi 0 to 4 r f of r dr. Okay, that's a really verbose explanation there. And then in part D is where we're going to have to actually use the calculator. So evidently in the same Petri dish, they've got some kind of complicated function that describes that. And for what value k is equal to the average value of g of r on the interval 1 to 4? Well, just a second. So average value of g on 1 to 4 is going to be 1 over 4 minus 1 times the integral from 1 to 4 of g of r dr. And while normally I would show you myself doing this calculation, I'm in a bit of a time crunch, so I'm going to just report this number. This is 9.8757948868. And I'm going to use all of those decimals because this is not my final answer. I want to find a solution to the equation g of k is equal to that average value, 9.8757948868. And then I will show you how I compute that one. Okay, so I've got myself a calculator, and I'm going to, in y1, type in 2 minus 16 times, and then they're opening a parenthesis for the cosine, because they're going to take that to the third power, 1.57 square root of r, and that, put another parenthesis. I don't think that parenthesis is actually necessary for the calculator. I think that was just mostly to make it really clear to you what they were talking about. And then, I mean, you could subtract the 9.875, but I'm just going to say, I'm going to put that in y2, and I'm going to run them into each other. Okay. Now, I know that this is really close to the default of 10, the maximum y value of 10. So I'm going to mess with the window a little bit. I think they said x is between 1 and 4, or r is between 1 and 4. And then y minimum, well, I know I'm interested in 9.875. So maybe I'll say 8 to 12. And I'm going to graph it. Be patient, wait for it to happen. There it is. And then 9 point whatever should just kind of cut across sideways. Yeah, there it is. Here we go. It's going to happen. Calculate the intersect. 2.497. All right, so I'm going to down here report that k equals 2.497. Oh, that's my main pin. So another thing about the calculator. Right, we use the calculator for an integral and then to solve an equation. If we're going to use it for an integral, we obviously have to write down the integral we typed in. I don't think that should be surprising to you. But sometimes people will forget that when we're going to solve an equation, we need to write down the equation that we're solving using the calculator. Okay, so I could see people forgetting to write that down. Okay, and that's number one. This one was honestly pretty typical of a table with context. On the AP exam, you're allowed to use a calculator. It had a Riemann sum. It asked you if that Riemann sum was an overestimate or an underestimate. Now, the Riemann sum itself came with a bit of a wrinkle, but overall, I feel like this was not too far from what we would expect.